بسم الله الرحمن الرحيم. Assalamu alaikum. In this slide, I want to talk about the KNN classifier. In the previous classes and videos, I talked about data mining and classification, and we talked about the neural network classifier. It is a very important classifier. We talked about perceptron and multi-layer perceptron. These are two important classifiers that we have. And continuing that subject, I want to talk about the KNN classifier. The KNN classifier is a very simple classifier that we have, and I will talk about it. The first point about the KNN classifier is that it doesn't have a learning model. Okay, it may be a bit weird for you, but this is what we have in some classifiers. We don't have a learning model. It means that we don't have a training process, and all the task of learning is done in the test process, okay, in the test phase. So we don't have a training phase, we only have a testing phase, and all of the operations are done in the test phase. So that's very important about the KNN classifier. This is called lazy learning. Okay, lazy learning means that we don't have a training process. And all of the learning is done in the test process. Okay, that's very important, and that makes this classifier different from other classifiers that have a learning model. Okay, the KNN classifier, it has two main phases, the train and the test. Like any other classifier that we have a training phase and a testing phase. We said that in the classifiers they have a learning model, and this learning model has some parameters, and these parameters are set in the training phase. But the KNN classifier doesn't have a learning model, so we don't have a training process. The only operation which is done in the training is loading the data into the memory. That's all we do in the training. Okay, we just load the training data in the memory. As we said, in the data that we have, some of it is for training and some of it is for testing. In this training phase, we are loading the data, the training data, into the memory. That's all we are doing in the training phase of the KNN classifier. Okay, and then in the test phase, what we are doing is this. For every test data, x test, okay, x test is a test data, calculate the distance between that data and all of the training data. Okay, for example, if I have 100 training data and this data is in the memory, okay, then a test data comes and we want to classify this test data. What do? First, we calculate the distance of this test data to all of the training data that I have in the memory, and then we get the nearest training data to the test data. Okay, so after we have calculated the distance, we sort the results, we sort the distance, and we get the k is a number. Okay, for example, k may be 5. We get the 5 nearest training data to the test data. Okay, and then among that k nearest training data to the test data, we select the class which has the majority, and that would be our prediction for the test data. Okay, so it's very simple. Every test data that comes, we calculate the distance with all the training data, and then we get the nearest training data to the test data, and then we select the class which has the majority of instances as the prediction. Okay, that's all the steps that the KNN classifier is taking to do the prediction. Okay, as we said, the KNN classifier doesn't have a learning model, and as you see in the training phase, only the training data is loaded into the memory, and then all the other operations are done in the test phase. Okay, this is an example of the KNN classifier. This is an example, and you see that we have some data. Some of this data are training data, and one of them is test data. Okay, you see it here. The data which are black and yellow, these are the training data, and this is the test data. Okay, this is the test data. Okay, so you see that we have some training and some test data. The training data has two classes, the classes of black and the class of yellow. Black and yellow, two classes. These are the two classes we have in the training data. Okay, so now what do we want to do? We want to say that this test data, what is the class of this test data? Okay, so we want to do a prediction. As we said in data mining, after we have done the training, we do the prediction with the test data. So the KNN classifier doesn't have any training. We only copy and load the training data into the memory. Okay, now in this example, we have assumed that k is equal to 3. Okay, k is 3. Okay, so what we are doing, we should calculate the distance between this test data and all the other data. Okay, so we calculate the distance between this data and all the other data that we have. Okay, after that we find the data that are nearest to the test data. Okay, as you see here, k is equal to 3. Okay, k is equal to 3. So we find the 3 nearest data to the test data. Okay, this 1, 2, and 3. These 3 data, 1, 2, and 3. Okay, these 3 data are the nearest data to the test data. Okay, 2 of them are yellow and 1 of them are black. So we have calculated the distance of all of the training data to the test data, and then we have selected the three nearest data. Okay, now we have to do the prediction. Okay, we see that in the nearest data to the test data, we have two yellow class and one black. So we say that the test data, our prediction for the test data is the yellow class, because in the neighbors there are two yellows. That's how the KNN classifier is working. It is working based on the neighbors, of the data. Okay, that's very important. That's how the KNN classifier is working. It is doing a prediction based on the neighbors of data. It assumes that the data has a similar behavior as its neighbors. So it's predicting based on the neighbors of the data. Okay, the nearest neighbors. That's the name of the classifier. KNN means K nearest neighbors. NN means nearest neighbors. Okay, the distance metric in KNN, it could be different. We could use different distance metrics in KNN classifier. We could use the Euclidean distance, the Manhattan distance, the Cassin distance, and all of these distances could be used. Some of these distances are have better results for some data. For example, the Cassin distance is suitable for text data. Okay, if we have text data and we want to use the KNN classifier, we could use the Cassin distance. Okay, the text data, before we could do any learning on the text data, first we should convert it to numbers, and then we could do the learning. Okay, so different distance metrics. Okay, the most usual one is the Euclidean distance, but we could test them in our data to see which distance metric has better results for our data. Okay, these are the formulas of the distance metrics that I talked about. The Euclidean distance is like this. If we have two data, A and B, each of them are a vector. A is a vector, B is a vector, and the dimension of A and B is n. The dimension is n. Okay, so we have two vectors, A and B, and the dimension is n. So the Euclidean distance between these two vectors is equal to this formula. Okay, we subtract the each of the data from different dimensions from each other, and then we get the square root. Okay, and this is the Manhattan distance. This is the formula of the Manhattan distance. Okay, and as you see here, the Euclidean distance is the direct distance between 2 points. Okay, the Euclidean distance is the direct distance between 2 points, and the Manhattan distance is like this. Okay, when you calculate the Manhattan distance, you're calculating this like steps. Okay, this is the what you are calculating. Okay, so maybe in some data the Manhattan distance would have better results for the KNN classifier. And the cosine distance is like this. Again, A and B are two vectors with n dimensions. We can use this formula to find the distance between these two vectors. Okay, so we understand that K and N is a very simple classifier. Okay, it's very simple. It doesn't have any training. It doesn't have a learning model, and all of the work is done in the test phase based on the neighbors of the data. Okay, so simplicity is one of the features of K and N. The other feature is multi-class. Multi-class. Okay, what does multi-class mean? Multi-class means that we have a classifier that could be used for data with more than two classes. Okay, some of the classifiers are limited to classifying only data with two classes. Some of the classifiers are limited for classifying data with only two classes. But multi-class means that the classifier could classify data with more than two classes. That's an important feature about the classifier. And the other advantage is the performance. The performance is of KNN is good in different data sets. Okay. Okay, some of the disadvantages. Some of the disadvantages of KNN is this setting K. Okay, we have to set the value for K. K is the number of nearest neighbors we choose to do the prediction. Okay, so we don't know the optimal value for K, so we could do it using some trial and error on a data set to see what is the good value for K. The other disadvantage is the time consuming test phase. Okay, in the other classifiers like the neural network, the training phase is time consuming and then the test phase is fast. But in the KNN, it's the opposite. The training, we don't have a training, so we don't have any time for that. But the test phase is time consuming because we have to find the distance of our test data with all the training data, and then we have to sort it, and then we select the k nearest neighbors. When we have a large training data set, okay, when we have a large training data set, this k and n would be very time consuming. Okay, when we have a large training set. But if the training set is not very big, so this classifier could be used. And the memory consumption is another issue. As we said, all of the data should be in the memory, so we could execute the classifier and find the nearest data to the test data. Okay, two important issues about k and n is that the k value, it could be set automatically. The k value could be set automatically. Okay, it means that we could design an algorithm to find the optimal k. Okay, some of the algorithms that we could use to find the optimal k is the genetic algorithm or other meta-heuristic algorithms like PSO, ACO, and other algorithms. Okay, these are the algorithms that we could use, for example, to find the optimal K. But we could do this by trial and error too. Okay, we could set K to different values and look at the performance of the K and N classifier and then decide about the K value. Okay. One other issue about the K and N is instance reduction. Okay, we could do instance reduction to have a faster test phase. As I said, the test phase in K and N is time consuming because we have to find the distance with all of the training data and do some and then sort them and then find the nearest ones. Okay, so this is time consuming. One option that we have is to instance reduction. Okay, it means we can reduce. Okay, we can reduce the number of training data. We could reduce the number of training data using some algorithms. So this is an important point that we set here. Instance reduction. Instance reduction means, for example, if we have a training data with 1000 data, okay, we could reduce the number of instances to, for example, 200 or 300. Okay, so this makes our algorithm very faster. Okay, these were the concepts I want to talk about K and N. If I want to review what I said, K and N is a classifier that doesn't have a learning model, and all of the tasks and operations are done in the test phase. We find the distance of our data with all of the training data, and then we find the nearest neighbors based on the classes of the nearest neighbors. We do our prediction. The KNN is very simple and could be used for multiple classes. As the test phase is time consuming, I could we could use instance reduction to enter the to to reduce the number of training data and make the KNN faster. Thanks. Thank you very much and goodbye.